While everybody's getting over here, I want to say welcome again, and thank you all for being here, and thank you for the sponsors and all those that organized the Tandy Assembly. I'm John Strong. I'm Strongware. I've been a Cocoa computer programmer and vendor for quite a number of years. So I'm currently, a day job as a senior software engineer, working for a defense company. And so, like, again, welcome. And thanks to all the people who come before me. They demoed some very, very nice demos. I'm glad you guys were here and let in before me. Great. Also, thanks to all the hardware people that's here. I'm going to do a kind of overall higher level. There's people here that's much more experienced and knowledgeable in the electronic side than I am, okay? And they built products to prove it. But I want to kind of focus things a lot on what things that we can do, even though we may not be the engineer, okay, and hardware. And the color computer was a great machine to work with that, and it's kind of a pick of many before the Arduino and the Raspberry Pi. It's so popular and stuff now. I had the privilege of not only being the president of our local color computer club, but also was a member of the color computer club in Kokomo, Indiana, at Doco Electronics, where I rubbed shoulders with a lot of the Doco Electronic engineers. And a lot of them supported Motorola products and the GM products. And so it was very natural for a lot of them to do that. And I got to see a lot of different little hacks and things that they did and information for them, and just kind of pushed me along in the path I did in development and interest in hardware and such like that. The 6009 is a great machine to work with. It has a great instruction set that works. You use this one instruction multiple ways in addressing mode. You can address anywhere within the memory map and do things. So it's really great for doing things such as that. And it's got a nice set of ports and that a lot of attention draws. One thing I've been quite interested in is different joystick configurations and things. This is kind of a CAD drawing of a product I'm planning to produce, just to introduce that. And the Cocoa, for the joystick port, it's a 6-bit analog to digital converter. It uses a 6-pin connector, and the Cocoa 3 has 2 switches on that. And so even right there, you could interface to those 2 switches if you wanted to do that. The drawback with that is they also share with the keyboard, and so you have to make sure you're not getting input from the keyboard and the switches at the same time. It's been used for a lot of things. You can use it as a keypad, the Tandy book, I believe they called it, with a notebook type thing. Had a flat membrane type resistive keyboard in it. I think it had like 1 to 16 or 1 to 10 or something. You had a cassette program you run, you use this to tap in the buttons on it. Of course, it's used for auto sampling. The 6-bit limit, that's very long. Of course, first was the high-res joystick adapter designed by Steve Bjork that came out for the Cocoa 3. But later, actually, a group of Cocoa programmers figured out how to do a high resolution in software alone. And so it has a lot of that. It can be interfaced with trackballs, arcade-type joysticks, Sega-style joysticks, light sensors, anything that you can change the resistance on a voltage within that range of 0 to approximately 5 volts. You could sample it as long as it wasn't happening too fast for the color computer to keep up with it. So it made a great way to interface the Cocoa, and it's quite an interesting thing. And it means it's simple. You want a light sensor, put a CDS photocell on it and a resistor, and wire it up correctly, and you've got a interface. So basically something most people that's in the Cocoa, they do any hardware at all, you could do that. and RS-232 port. Of course, the communication, we had a 3-port one, and also make a reference, I did do the diagrams from the Tandy Color Computer 3 reference manual that's available on the Color Computer archive online. Of course, the standard serial communications, okay, the printers, the modems. One thing that's very dominant in the COCO is drive wire was used, which means you don't have to have a drive system in that. You can connect to a PC or whatever it was. What to do is serve drive wire and communicate with that. And that's something actually Boise started that, I believe. He's here. Thank you, Boise, and everybody else who worked on it since then. It's a great system to communicate with. And then MIDI. MIDI is kind of overlooked. It's kind of like a network in hiding. It's slow speed, okay? 31 kbs, fast maybe at the time, but it's multiple devices and bidirectional. And we'll talk about that a little bit more. Cassette board, of course, the tapes, audio spectrum analyzer, okay? Home controller used it. I played with the use of the relay to dial a phone. Of course, audio in and out. Has a zero crossing detector and so on. So these are all ways that you can interface the COCO and not have to know a whole lot of hardware design. And some interesting things have been done with it. Here's a unique one. It's COCO 3 only, but I knew a guy who actually interfaced to the spare pin on the RGB cable, resistor and a capacitor or something, and I don't remember what all the parts he used, but I think it's just a couple things. And he's able to shift the timing on the video signal down about a half line. A normal TV signal is interlaced, okay? So he's able to keep turn the non-interlaced signal from the COCO into the interlace and create a double resolution high on the screen. And that's just out of the box things, thinking of things that could be done. That port could also be used as the input. But when we think of interface in the COCO, usually what we're thinking is the expansion port, like the cartridge port or the disk drive port. And the COCO just had a game cartridge type port you plugged it into. And some of the signals that we have there, we got it up on the screen. The HOT is used in the floppy controller because the floppy controller runs a little bit faster than what the computer can keep up with. So it halts it. There's no halt controllers that was designed. But also you can stick something like a little timer on that. Slow down your computer if you wanted to see stuff. So they brought a lot of signals out there that can be useful. You have the interrupts for timers. You could actually reset the whole thing from the port. Okay, your E and Q clocked. We were talking earlier this morning. He talked about using the oscilloscope and things to look at the E and Q clocks. The card, it's the interrupt input port. Okay, basically fires an interrupt, and similar basic is fired to look and jump to an address in that card to fire it up. It's used for game cartridges. But you can also use that interrupt for other things. You have the sound inputs. If you have sound on that card, you can direct it into the system. And then we have CTS, which is the cartridge select symbol signal, which gives you the address maps the ROMs in. Okay, and the SCS, which is spare chip select, but this usually for a port for like your floppy controller is things. And that means you didn't have to have any decoding hardware within the cartridge if you used that address space. And then actually there's a signal that was rarely used that you can disable a lot of the addressing built in the computer and take over that. This opens up a lot of possibilities of things doing that. And today with the microcontrollers and stuff, you know, some of the whole classic parts are hard to find, but if we do level translators, chips, and we can use microcontrollers now, sometimes just to emulate parts that you can't find anymore. And one of the things this year at the Cocoa Fest was people using Raspberry Pis, the Pico or Pico, whichever way you choose to pronounce it, to interface things. We have things like FujiNet that's using controllers and doing network things and connecting the internet. And it's all going through this expansion port. And it's been kind of a long time. It's been expendable with what we call a multi-pack on the Cocoa. It basically gives you a slot bus in there. The standard multi-pack comes with just four slots, but you can use the same switching protocol to handle up to 16. The card selected for ROMs. And one thing, like I suggested to Jim Brain, who has designed a multi-pack that does 16 slots, is you can actually use that SCCS, remap that to other addresses, so we could have duplicate things without having to use that address. If we remapped that SCS in a multi-pack, we could have 2 floppy controllers in it without no hardware modification to the cartridges. There's a lot of possibilities still left in there that hasn't been done, but there's all kinds of things that's been done with that. The Y cable was actually made popular with Cocoa Max, because they had a hardware high-res interface on the first wasn't the first graphics program, but this was a Mac-style graphics program for those who are not familiar with the Cocoa. And it really changed the face and what people thought could be done on the Cocoa, because it really did look like a Mac, maybe a bit lower resolution, and so on. A lot of times they use a Y cable because you could use a floppy drive with it. So things are brought out. And being a Motorola chip, again, you can use those instructions, the in-disk addressing modes, direct page. If you need to move something really fast for your port, set your direct page register so it's on that 256 byte block of it. And then it's like very quickly you can do your output, input through it. And so it makes a very nice system, I think, to interface to. And with that, custom expansion ports. You can build your own. There's now proto boards you can order and buy. KiCad, kind of designer, is free. In fact, I just ran across a new book from the Raspberry Pi Foundation. It's talking about teaching how to use a lot of stuff, doing it, set up the multiple pages to make things more convenient. And I have a chance to read it all. I kind of skimmed over it. It looks pretty good, covering a lot of topics. So if you're interested to make your own PC board, that might be something you want to check into. You can go to the Raspberry Pi websites and find their books and find that. The chapters might be online to find somewhere. Of course, you can hand wire your prototypes, which is point to point. Sometimes I use a modified wire wrapping, use a sender socket because I'm not going to do that many levels. Wire wrap it and solder to make it do that. If you want anything other than that FF40 address, then you're going to have to do your address coding. But there is chips that's called magnitude comparators. You can set up a dip switch, and then you compares that to your address and select that. So there are ways to do that. The PIAs, peripheral interface adapters, and then I think there's the ACIA and other things that also were designed for the Motorola type bus. But you're not limited to that. And the disadvantage of the PIA, because they have multiple ports on it, you have to program them and set up what registers you want to go. And sometimes you want something simpler than that, and you simply do some kind of latching mechanism and not have to program that chip. The PIA gives you advantages. Yeah, I can change that bidirectional, select those what I want, and change the ports. And the PIAs are used in the Cocoa. And so people may be used to programming those because they've done that to change things, setting up modes for the graphics and things like that. Voltage translation, if you knew the new products, the Cocoa is, of course, 5 volts And you're going to have to accommodate the things for like the 3-volt processors and chips to do with that. I want to go ahead and kind of run this a little faster than what I thought I would be doing. But MIDI boards was a really kind of really cool things. One of the things that spun off from the Delco Color Computer Group was actually a MIDI group. And they used it not just for music, but also controlling things around the house. As I mentioned, it can be used as a network, and it can be bidirectional. MIDI actually has a MIDI exclusive command specifically designed to send things that's not music over that MIDI type network, and it's bidirectional. I'm going to stop here a minute, and anybody comments or questions you want to make at this time? Yes.
The expansion bus is known for having a CPU.
You'll have to speak up a little bit louder. I can't hear.
Sorry. The expansion port of the color computer brings the CPU lines right out to the port, right?
Yes.
Most. A little careful, right?
There's a little bit of it that's buffered, and also there's some. Mark makes a buffer for the CPU as well, and there's a couple. He asked if it brings the expansion port lines out to, for the CPU lines out to expansion port, and most, yes. Some of those are buffered. We have some addresses that decoded, some things that decoded a couple of lines. But you get most of the stuff there. I think there's one of the items that allows you to hook multiple CPUs that doesn't come out, or the DMA doesn't come out. But most of the stuff does come out the port. There's a few missing items that have been nice that they would brought it out. So you can tell they really didn't design it originally as that big expansion bus, same as the original TRS-80 didn't really design it real well for the big expansion bus, which caused all those problems, which got it the nickname as TRS-80, because if you didn't have that cable there right, and it often crashed the system. But it does bring out a very good usable subset. We've had a lot of different products on it. And still more things do that. We have people's design, though. We have game cartridges now with sound on it. Thank you, John Linville, for the Game Master cart, and et cetera. So we have sound chips, we have synthesizers, all kinds of things that plugs into it. We have third-party multi-packs that have still been produced. Even a mini one has just 2 cartridge ports. We have a 4-cartridge one. Jim had designed a 16-slot one, but every time I see him, I keep asking when he's going to finish it up and produce it. A little bit of pressure there, Jim. He's used to it from me, I think, though. I think I see a smile on his face back there. But still a lot of possibilities to be able to do that. And it's fairly easy to interface and use it with. Okay? Anything else? Okay. And I kind of didn't break this out there because there's so many ways we can go with open the case. When you open the case, now you can interface a lot of different ways because you've got basically access to all kinds of things. And we have some exceptional products that's been produced for it. And Brandon, a shout out to you for the Coco VGA. So on the Coco 1 and 2, you unplug the 6847, plug his board in, and boom, you've got a lot more display options. Remap the character set, and that's something you can talk to Brandon about, at its booth. And then we have the Coco X, which replaces the Gimme chip, which is the video controller chip, and the Coco 3, and with extended features on it. We have multiple memory upgrades. We have extensions. We have a address decoder that allows you to do banks in the Coco. They've expanded that to, what is it, out to 8 megs now, something like that you can add to it. And originally it was like a max of 512. A simple little thing I did, you can use a 3 to 8 TTL decoder and monitor your CPU states. I built a few LEDs off of it, poked them up through the top of the vent slots, and I built that after having a chip filler on where the HALT wasn't functioning properly. I think I had to replace the CPU in that case. Also, some of the early floppy controllers, one of the TTL buffer chips had a tendency to go out on the HALT line, and allowed me to see if when the computer was halted, what state it was in. And it was simple, well, one chip TTL that brought out to that. Of course, monitor drivers, it's basically the Coco 1 and 2, so you get a composite output. You can add new keyboards. You get interfaced all kinds of ways with it. And so it very opens up, but the built-in ports give you a lot of flexibility, open the case, and you're kind of wide open on what can be done. Plug in CPU replacements, field programmer gateways that plug in and replace the CPU with 6809. So you can do things like in-circuit emulation. Those exist for the color computer. And a lot of things can be done with it. It's a nice little box, okay? And it does a lot of stuff in a fairly small package. Very hardware hackable, I would say. Okay? Open floor. Ideas, questions?
If you're looking to get into, kind of get started with the interface in one of the Cocos, is there a particular resource or any sites outside that you would recommend?
Okay, he's asking how to get started with the Coco as a resource. Well, first the resource would be the technical manuals available for the color computer. There's also multiple memory maps for the color computer out there which you can get and look at. Nowadays, I'll go play with the Arduino a little bit. Do some of your interfaces, do some maybe your testing with that. Because they're a lot easier to replace than a Coco is. So if you make some mistakes, let's do it on some cheap hardware. Get your ideas out, test it out, then translate it to Coco. It might be a good place to do. I wouldn't have said that a few years ago, but the Arduino stuff from China and stuff's so cheap. They're throwaway, You wire it wrong and blow it, okay. Pitch the part, grab another one out of the parts box, and go for it. But I would say assembly language is a good way to interface with it, but the Coco does have the peek and pokes, okay? So you don't have to go assembly language to do it, but you get a lot more flexibility and speed if you do assembly language. Yes?
Yeah, I just wanted to know, you would get all of this, the color computer archives.
My slide thing?
No.
Oh.
To get these manuals.
The main manual, the tech manual, if it's a printed manual that was published, the Color Computer Archive has most of those. You want to know where to get those. Some of the other documents will be on the Color Computer Archive. Some of them are other locations. I don't know exactly what those are, but there's been multiple versions on it. There's assembly language references out there for the 6809, for the 6309. There's multiple ones out there if you want to use that as a different CPU for it. So references are out there, but the Color Computer Archive is a very good starting place. The Coco mailing list is another place you can ask questions. Discord channels, they're pretty big. I really don't go there very often, but also the Facebook groups are very open to questions and asking, okay? So if you need help, just reach out and say, hey, I need this, so you're there. Somebody may have done it before. I know a guy was building a interface. He wanted to interface a standard PS2 mouse to the Coco. And I had looked at, and I pointed him to several resources and says, okay, now I don't have to build it. Because it was something I was thinking about building. And so a lot of the Coco community, I think, is very good on sharing information and ideas. And very welcoming to other people coming in and asking questions and help. To answer your question good enough. Any other? Yes.
Do you have a recommendation for what you would think would be the best emulator or emulators for the Cocos 1, 2, and 3? Like in the Z80 side of it, we all say TRS-80 GP. That's the
Well,
king of emulators.
Okay, he wants to know what a recommendation for the emulator for that. Well, the MAME emulator is very good and very accurate. The XWAR is very psycho-accurate and things. I generally use VCC. They're all very good emulators. Okay, just because I use VCC longer. Okay, so I know how it works a little bit, and I played with the source code to add extra things to VCC. But all three are very good emulators. Okay, sometimes it's depending what you need. The debug is probably the built-in debug on MAME might be the best. It's a little hard to set up with. XWAR we use there's a version of the debug, I forget what it's called for GCC. There's a version for the 6009, and XWAR has it built in so it can communicate with that. VCC has a way to load in symbol tables and stuff for debugging, for single stepping with that. So they're all working toward that. So it's kind of pick your choice. You know, you want Pepsi, Coke, or RC kind of deal. They're all very good, but a bit different. And I will say I do a lot of my Cocoa development with VCC and assemblers and stuff on testing and stuff. It's just so much faster than booting up and doing on that. Because back when I was doing my development on the Cocos, on the Coco 1, I used the JNR Banker. We had it like, I think we finally got to 512, I believe. And I used that as a RAM disk to speed things up on compile times. But if I would do a compile for my game, I assemble my game from assembler, and I could start it and go out, eat a snack, and come back and she'll be working on it. And if it made a mistake anywhere during the time, then I have to restart that over. And so the RAM disk solution was really a great help. The de facto standard for the color computer now is one of the cartridges that uses the SD cards and stuff, and we do that. But there's a lot of ways to do it and different ways to do that. But like I said, the emulator is a good way to check things out, and there's three very good ones that's used widely in the color computer community. And I'm sure there's others out there that's probably good as well. But XWAR, MAME, and VCC are the main ones you see that primarily used on that. And now a lot of guys are going and using the Cocoa Pi distribution for the Raspberry Pis and using that and doing their emulation on that. Okay. Anything else? Anybody else a question? Comments? Okay. Well, I think that's what I have. Again, thank you. Hopefully it gives you some ideas. You know, throw away the box, decide what you want to do, and then look back at it and say, okay, can I fit this in? Or how much of it can I fit into the box? And it's a cool machine to play with. Or wouldn't you be playing with it these many years?